All right, these are just general words they would use. Sometimes they would change the words around. I'm using horizontal shift, vertical shift, horizontal shrink, horizontal stretch. There's also amplitude is also known as the vertical stretch, vertical shrink as well. So amplitude can also be known as vertical stretch or shrink. Okay. So let's go through that one more time, right? So let's go back to the start. So you're given an equation and you get all of these parameters, all right? Whatever, it's just going to change the nature of the original graph. So you got your original graph and you put a number in front of it. Suddenly you're going to stretch it or you're going to shrink it. All right, there's sine x versus sine 2x. And if you put a negative in front, it just flips the whole thing around. If you put a number next to sine before x, it's your horizontal shrink or horizontal stretch. It's also your period adaptation. So you take 360 degrees, and a period, remember, is one cycle. So one cycle can be short or long. This one is 2 pi ending, this one 4 pi ending. So in this case, b will be 1. So we divide it by b. We divide b into 360 degrees to get the period. And here we go. 2 pi divided by half. So whatever's in front of x, we divide it into 360 degrees, or 2 pi. And that gives us the period. Opposite sign plus c, this is your horizontal shift, moving the whole graph left. So again, positive is left, negative is right as well. And then lastly, a vertical shift, which is going to be positive up, negative down. All right, now let's look at an example of this. Let's suppose I have y is equal to negative 2 sine, let's just use 2, 2x plus 2 plus 2. And let's say we want to draw or we want to sketch this graph over here. If I start from the original graph, sine, we know that this graph is going to end at 2 pi. Firstly, it's going to flip over, okay? So let's flip it over. All right, then we're done with that one. The next thing is, it's going to go as high as 2 and as low as minus 2. Okay, so we're done with that one. Then after that, it says that the period is 360 divided by 2, which is going to be 180. So this graph is going to end at 180 degrees or pi. But then we take the whole graph and we shift it 2 units to the right. Most probably, let's keep it in radians. So if we shift it 2 units to the right, this is 3.14. This is 0. So this is going to move all the way to the left. Because it's positive, we go left by 2. So we're going to go like this, and the graph is going to shift left. It's going to start at negative 2 instead of 0. And it's going to end at 1.14 instead of 3.14 because it's going 2 to the left. All right, so wherever that looks, probably much more like this. I think 1.14 is going to be like somewhere here. So that's negative 2, 1.14. And now I've shifted it left by 2. And then you take the whole graph and shift it upwards. So every single point goes up. And that will be my final curve that I would have. Just a quick idea of how that will work. Let's go through a bigger version of it. Okay. All right. Here we go. So let's say we want to sketch y equals negative 2 cos 3x. And let's use degrees this time, right? Let's say x minus 90 degrees. Let's move it 90 degrees to the right. And let's also shift it up by 4 units. Okay. Now remember how many transformations we got here. We got 1, 2, 3, 4, 5 different things that we've got to do to the original cos graph. But we always start from the original cos graph because it gives us a good idea. And keep a pen and pencil. I mean, keep a pencil handy because it's easier if you have a pencil. You can erase it and then just adjust it along that. Okay, so that's my y. That's my x. And this is going to be my original cos graph. I'm just going to draw it until 360 for now. So that's 360 degrees. I'm using degrees, not radians. Okay, that's the original. That's none of this. I haven't applied any transformations yet. Let's go ahead and put transformation number 1 in place now by going the other way. We are now going to go the other way. Okay, but then at the same time, after we've done that one, we now want to stretch it. We want it to go up and down to 2. It's going to go up to 2, let's say, and to -2. So the graph will now shift up and down from there by 2. I mean, up till 2. So because this is 2 in front, it's going to go up till 2. So let's see, it'll be something like that, going through the same coordinates, same points, but we've sort of stretched it. Now, this is just a sketch. You can see the original graph supposed to go through 1. I didn't really draw it to scale. Okay, so that's part 2 done. Now, part 3, once you've got this one, let's erase the others, right? I'm going to erase all the others. If I was writing it in pencil, that's where I'm at now. Part 3 says I've got a period change of 3 in front. So remember, I take that and I divide it by 3. 360 degrees divided by 3 equals 120 degrees. So this whole graph is going to shift inwards. So it's going to do something like that. And it's going to end at 120 degrees. Let's just sketch it and say it's there, because I'm going to erase this anyway, right? So I'm erasing that, erasing all of that. So if I am on craft paper, you'll probably see it more clearly. So now I've applied the period change by dividing it by 360 divided by that is the 360 becomes 120 after dividing it by 3. Then I got x minus 90. I'm now going to shift the entire graph left by 90. Yeah. So every single point that was 0 becomes -90, for example. So this whole graph, if I have to, I can just draw a dotted line at -90. Now, keeping it sort of consistent to what this looks like. I know halfway is 60, and halfway here is 90. It should be there where it goes through. And this here should be 30. So looking at 90 should be around that length. Let's say -90. Again, this is a sketch. This is not accurate, right? So that's where I want to shift it all the way left. Take each point and go 90 degrees to the left. So this is 0. It's going to go there. 30 minus 90 is going to end up at -60, which is, let's say, there. Now that actually doesn't look like -90. Let me just change it up. That looks like -50. I'm going to quickly change it up to negative. Let me just make it similar to this one here. -30, -60, -90, and then -120 somewhere there. So let's say -90 is over there. That's good. -90, -60, -30, and then 0. Going backwards. I'm going to shift that point all the way this way. Oh, by the way, did you notice I'm actually shifting it in the wrong direction? I'm supposed to be shifting it right, okay? Because it's -90. All right, so I'm going to make it into a positive. All right, let's stick with this. I'm going to make it into a positive. All right, so we can just see how this works. This is going to be positive 90. Remember, opposites over here. We're working opposites. So positive 90 goes all the way back till here. And if I go and flip up the exact same thing, I'm going to be going 30 before I cut, another 30 before I turn, another 30 before I cut again, and another 30 before I stop. So the graph will stop over here. Maybe I will make some dots, maybe, and then it's going to peak at this point at 2, by the way. It's going to peak at 2, not there, right? So this graph's going to go a bit higher and then back down there. So the graph should sort of do that. And now I've applied the shift. Okay, erasing that now. Final answer now is to shift the entire graph up by 4. Now that's, I don't have space here. All right, so this is going to go up by 4. Up 4 units. So 2 is going to plus 4, and negative 2 is going to plus 4, and 0 is going to plus 4 as well. Okay, so every number is going to plus 4, so this is going to become 6 over here. This is going to become 4, and this is going to become 2. Now I'm just providing this everything assuming in pencil. All right, so where does that leave my new, where does it leave my axis now? My axis has changed, right? My entire axis is going to change. If I have to move this entire axis, if possible, let's see if I can. I'm going to move this entire axis down with the 4. I'm going to make it 0. It's going to be somewhere at the bottom here. All right. So the new center of this is actually going to be 4. It's a bit confusing to see the 4 there, so I'm going to take it out. Just put a 0 there. All right. So let's put the 0 over there. Okay, it's not accurate. This is not accurate at all. So this is going to be my new central line 4, and you can see the entire graph, which was at the bottom, is now here. So this is now going to be my central point over which my car's graph is going to be turning, because I've now shifted it up by 4 units. Labeling your graph under a sketch model, make sure, otherwise you will lose marks. But if they ask you to draw it and you give you graph paper, obviously it's going to change. Now, how do you do this a little quicker? If I have to do this a little quicker and do it in one go, once you get used to it, and let's see if I can neaten this up a bit. All right, so I'm going to try and neaten this up a bit, and let's see if I can put this all 5 steps in one go. I know where it should go. So what I do is I do this. I draw a sketch, which is not accurate, like I said, but hypothetically correct. Okay. So I'm going to draw a normal cos graph, upside down cos graph, a nice one up till there. I know it's an inverse, so I'm done. I'm going to assume that this number is 2 and negative 2, so I'm done with that. I know I'm going to go for 120, so I'm done with that. And I'm going to shift every point left by 90. So what that means is that this is going to be my new axis, because this is 30, no, 30, 60. This is going to be my new axis here, right? So that's 90. If I shift the whole graph left, then this is going to be where the graph is 0, okay? So I'll keep that in mind. So I'm going to draw a quick line here, through here, at 90, and I'm going to change that into 0. Change that into 0. So this is like a quicker way of doing this, right? I'm going to change this into 0 degrees, and then obviously everything will change accordingly. There's not much erasing involved there. Now I've shifted the graph left by 90. That means it will stop at 30, and it will start at negative 90. It will also go as high as 2 and as low as negative 2 at the bottom there. All right, and that's my y-axis, that's my x-axis, and all I got to do now is shift the whole graph up by 4. So that means that I plus 4 over here, so this becomes 6. Again, plus 4 over here, so this becomes 4. Plus 4 over here, this becomes 2. So which means, where will 0 be? 0 is going to be roughly around at the bottom here. So I can draw another line and then erase that. So I draw another line at the bottom here. This is going to be my 0 line, my new 0 line, going straight down from there. And I now erase all of that. Oh, I could relabel it actually on that before I erase it. It would be a good idea to just label this 30, label this negative 90. This is my new x-axis because I shifted it up, and I could then now change those values into it. This is like a neater, much more neater form just quickly sketching it in one graph together. Now I know the height of it is 6. You'll notice that this becomes your new axis. Okay, actually your new x-axis. So that would be the central point over there. That's my new x-axis. And that's going to be 4, which means it's plus 2 because the amplitude is still 2, and minus 2 means it still goes down for 2. So it's still going up by 2 and still going down by negative 2 on either side. Okay, so that's going to be sketched from negative 90 till 30. We could extend this depending on the domain. All right, keep a pencil handy and erase whatever domain they've given you. So let's say the domain was given, ensure that x is greater than 0 degrees, but less than, I don't know, let's say less than 90 degrees. Okay, sketch for this domain. So this is 30. We know that this point over here is 60. And we know that it turns at 90 and it stops at 120. So which means that the graph is actually what they want us to sketch is only from 0 up till there. So the graph will be non-existent before that. All of that will be non-existent in this first part over here. So the graph is literally going to go from 0. Let's just double check that. So it was, yeah, so it's going to go through starting from 4, 0, curving very nicely like that, and then stopping with 0 now, curving like that, and so just drop it and stopping there. I'm going to do it in sequences. There we go. There we go. Done. I've now started from 0 till 90, and that's the only thing they want to see. Erase all of these other spots everywhere, neaten it up, preferably in there. All right, that's the domain for that. Okay. Now the 10 graph, you can do this. You can do this for the 10 graph is slightly different. Let's have a look at a quick example of a 10 graph. Let's say you go y is equal to negative 2 tan 2x minus, let's move the 10 graph 90 degrees to the right. And again, this can be pi over 2, right? In radians, plus 1. Original 10 graph has a very special point which you have to note every single time, which is the 45 degree point. The 45 degree, 10 of 45 is 1. It's root 2 over 2. It's a special angle. And so if I got my negative 90 over here, and I got my positive 90 over here, and I got my 10 graph, which is simply going through there and coming up otherwise. So it's going to go like this, and this way, coming back up this way. This graph will, on a normal day, at 45 degrees equal 1, and at negative 45 degrees equal negative 1. It then repeats itself in that same fashion with the asymptotes, at negative 90 and 90, etc. Now, starting from this here, the first thing I can see is that the graph is to go the other way. Okay, so let's change it up and go the other way. So we're going to go starting from bottom left to top right. I'm now going to start from top right to bottom left. And it's going to cut through this point, which is negative 45 and 1 now. It's going to cut through 45. So these are my guidelines, almost like a guideline to this negative 45 and 1. It's almost like a guideline to ensure that I get the best possible shape. All right, so that's going to be this way. This is going to be this way. right? That's the best possible guideline right this way and that way. And I'm now I've now inversed it. But now I'm going to increase the amplitude by 2. So what that does generally, it increases it, like it's going to go more higher. All right, so it's going to actually cut through negative 45 and 2. Okay, so the whole graph stretches like this, goes down up till negative 2 and 45. Again, that's a guideline to get you that shape, that inside shape. So I've now stretched it a little bit higher. Okay. What I can do to save myself the effort, I could, if I'm just sketching it, I can just change these two numbers into 2 and negative 2. And I've now done both of those for the middle, right? For the middle one. Let's get rid of these ones as well, they'll follow suit. Then I have to now take, now the period of a tan graph is 180 degrees, so we divide that by 2, so it's going to become 90 degrees. So that means the length of one cycle is not 180 any longer, it's now 90. So that means that I have to start at negative 45 now, and I have to end at 45, because that will ensure that the period is now 90. Okay, so I've now changed the period to 90, and I'm done with that part. Now I'm going to shift the whole thing 90 degrees to the right. That means that this whole graph is going to move 90 degrees to the right. What will that look like, right? So if I have to move this whole graph 90 degrees to the right, it's going to go something like that. Okay, so it was here, negative 45. It's going to go, I'm going to probably need another line. So starting from 0, it's going to go up to 90. Let's make a marker somewhere. Let's make a marker over here, 45, 90 is over here now. This line, this y-axis is going to move over here, but not the y-axis, just the graph. Okay. Everything else is staying the same. Now remember, we're plusing 45 from the central point and minusing 45. So that means I'm going to minus 45 and plus 45 as well. So this is actually going to go here to 135, and the graph is going to be sketched like that. Yeah. That takes me to 45 plus 22.5. No, sorry, 45, maybe negative 45 and 1. This, by the way, has changed to 22, negative 22.5. This was also changed to 22.5 because it's exactly half. I'm now going to add 22.5 to 45 to get that point. And that has to be, it's supposed to go through here in 2. And then plus 22.5 to go here. This one looks like it's gone through. And that will be the graph that was there. So what have I actually done? I've actually just rewritten the same graph. Now, if I have a certain domain, this original graph already allows me to get that repetition anyway. So shifting a tan graph left or right 90 degrees after you've reduced the period to 90 degrees means that you are drawing the same graph. So these two allow each other to be the same, because this graph, without shifting it, will still do exactly that, and it will repeat itself anyway. So by shifting it right by 90 degrees, it would be dependent on what the domain is, or whatever the domain is from there. Okay, so I'm going to just sketch it anyway. So we have that ready there. We said this is going to go right till there, and this is going to go down till there, and that's nice and simple. All right, now let's say the domain. Now this is going to be the decider. The domain is between 45 and 135. If they tell you that that's the domain, then the first graph is not what we need. We need to erase it. We need to only show the shifted one. Or even if I shift it, it will map it onto itself anyway. So that is the actual domain that would have. I've now shifted it 90. but it doesn't matter. Plus 1 means that the whole graph shifts up by 1. Now, what does that mean? It means that all of these go up. Instead of 2, it's going to go up to 3. Okay? So everything that was is going to become 3. So this is going to go up to 3, not was 3 actually. This is going to go up to 1. It was at negative 2, but now it's going up to 1, and that critical value over there. Don't forget that this is 45 degrees. This is still 90 degrees in the center, and this is 135 right at the end. And with the eraser and a pencil, being asked to sketch this in a test. Most probably I'll ask you to interpret it, but if you can sketch it, you can interpret it quite easily as well. So these points here, I'm going to plus 22.5, that's 67.5. That's half of 45, right? 67.5, then plus 22.5 here will give you 112.5, I think. Yep, 112.5, and that's going to be those critical values for this. And I've now shifted the entire graph up. You can see that's the new central point, which is at 1. That's where the graph is reaching its point of inflection, where it goes from going to your second derivatives. Remember, that's where your second derivative of x is also equal to 0, or we exchange it from a positive to a negative, right? Indicating concavity changes. All right, so that's how you would sketch cosine and tan for that.